I had a chance to chat with Barry Leffer a few days before he left for the start of KORUS-AQ, and I picked his brain about why we should be studying air quality over Asia in particular. Hey, so Barry, tell us why we need NASA to study air pollution.
Well, it turns out air pollution is a global problem, and the best way to see the global view is from space, from satellites. And it's amazing when the first global satellite of measuring air pollution from the space shuttle, all the surprises we saw that we didn't expect. So that's really exciting.
But measuring air pollution from space must be tough. I mean, you're talking about small particles and gases and things. How does that work?
Yeah, so it turns out very small amounts of air pollution can cause human health effects. And so it is indeed a challenge. And part of it is that clouds get in the way. And also, we're measuring the whole column of pollutants, and what we care about is what's really down at the surface. It's amazing over the last 10 years, the improvements we've made in understanding how to take that column and what is at the surface.
And now KORUS-AQ is going to help us with that, but you're going to use, I think, something like 3 different airplanes and some stuff on the ground. Tell us about how all that comes together.
Yeah, it is indeed a lot of coordination involved, and we're working with our Korean colleagues closely. It turns out that we need multiple views of the problem, and so we have the NASA DC-8 making these walls, and then we have the NASA King Air flying high, looking down with an airborne simulator. So it's exact duplicate of the satellite, but since the satellite's not launched yet, we can actually see what the satellite's going to see from this higher airplane.
Now, why Korea, right? The KO in KORUS is Korea. Why did you guys pick Korea?
Well, we could have gone anywhere in the world for this study, any megacity, but the Koreans, we have a special relationship with the Koreans. They're building a sister satellite to the NASA Tempo satellite, which is going to launch in a few years. And so we want to work on how to calibrate and validate that satellite before it's even in space.
Okay, now tell us, how does all this data come together in the end? To explain a little more about how our world works.
We're going to spend the next 2 to 4 years after we get the data analyzing it, modeling it, and writing scientific papers and presenting them at conferences. And I'm really excited and looking forward to the results.